Hello, welcome back to yet another episode in CSC 280, the Introduction to Cybersecurity. In the previous two videos, we talked about vulnerabilities and vulnerability disclosure. Today we'll talk about how we manage the whole process of vulnerability management and how we determine how bad a vulnerability actually is. So, I mentioned this before. Vulnerability management is the bread and butter of a cybersecurity team. In many cases, if we can get our patches out to our installed system base as soon as possible, we avoid a whole lot of pain down the road. It's bad enough that we have to deal with system compromises from time to time, but when a system is compromised because we were not quick enough deploying a patch, well, to be quite frank, that's kind of embarrassing. We know that we need to do this. We do have tooling in place. We know it takes time and it's difficult to do, so no one expects immediate results, but we do expect some ability to deploy patches rather quickly. Now, that sounds a whole lot easier than it is. And when you're at home as a simple consumer, the process is really not all that difficult. We turn on our computers and the thing pops up and says, oh, there's updates waiting for you. You have to install them now. And then we go, oh man, really? And now we have to reboot this computer too and wait for it to reboot and apply all of those patches. I'm going to lose a whole 15 minutes out of my day and I just don't have the time for doing that. Well, in the end, 15 minutes out of your day once a month or so is still a lot faster than having to recover all of your data because, for example, you were the victim of a ransomware attack. So patching, as annoying as it is important. If you're dealing with one computer, it's one thing. Two, maybe. But if you're dealing with an enterprise network where you might have hundreds, if not thousands of endpoints, it becomes a whole different story. First, before we can figure out what we need to patch, we need to know what we have, and that is a hard problem to solve. Do you know what software is installed on your computer? Every single bit of software that's on there. My guess is that no, you don't. You might know a good part of it, but you don't know all of it. And now multiply that at scale to an enterprise network. So for some, what seems like an easy problem is, just update your software. Step one is knowing what you have. Because if you don't know what you have, how will you possibly know that you need to update it? Or can you even check that you have updated it? So building your software inventory, what is deployed to your endpoints and to your servers, what specific version and patch level of each particular title is available to your end users, is a daunting task in the first place. It's very hard and very rare that we have an organization that can clearly and confidently say, yes, I know everything that is connected to my network and every piece of software that's running on my computers. Yet it is something that, for a full vulnerability management system, you probably have to consider. So instead, we focus on high value targets, we focus on servers, we focus on computers that are imaged according to the same baseline. But it doesn't mean that that's all there is. That might be all that there should be, but that these two aren't always the same. So just trying to figure out what you have is hard enough. Now, all we have to know is also, assume that I know every piece of software on my systems. And I know specifically what version of the software I'm running and maybe even at what patch level. What I also need to do is now keep track of the manufacturers of all of those software titles and keep checking in with them to see if they have released updates and if those updates are for security fixes. Unless I do that on a regular basis, or more specifically on an ongoing basis, I might have an inventory, but I need to be able to map that inventory to what's available out there. Because if I don't have that mapping, I cannot assess the gap. I cannot figure out what software I'm running on my network that should have been patched, and at how important those patches were and how quickly they need to go out there. And so once I understand what the gaps are between the latest software put out by the vendors and the software that I have on my network, I can start looking and saying, okay, what are those gaps? Are they important, or are they just minor fixes of something that is not that important? I need to assess that risk. And at that point, once I've done that, the question becomes, okay, which of those patches do need to be prioritized first? For example, as I am recording this, a couple of days ago, maybe a week ago, Microsoft announced that they had released a patch for a vulnerability in their DNS system. DNS is the internet system that resolves names to IP addresses and vice versa. It does more than that, but that's good enough. And it turns out there was a problem with that could potentially lead to remote code execution. In other words, an attacker who would exploit this vulnerability could execute code on my server, and they could do so from far away. And that's bad, especially if that can be done unauthenticated, where I don't even have to ask that person who they are, but I can just show up at my server and say, here, run this. So at that point, I need to mitigate that. At that point, that was a patch now. That was the highest category of risk, because one, DNS servers are critical infrastructure servers, but also because they were very, very vulnerable. So the combination of those two, impact and likelihood, was very high, and so we needed to patch that immediately. While there might be other patches that I'm okay with waiting for a week or maybe even a month before I deploy those patches, depending on what system, where the system is deployed, who has access to the system, what the capabilities of the vulnerability are, if they're exploited, all of those things. And so it's just a 4-step process of identifying the software, maintaining some form of vulnerability intelligence data, in other words, knowing what has been fixed but I haven't deployed yet, assessing the risk of what I haven't fixed yet, and then of course mitigating it, which is actually the fixing part. It sounds very easy, but in practice it's very, very hard, and it's really an ongoing job. This is all assuming that I have vulnerabilities that I can fix and that I can find. And so if those fixes are available, and we saw that as the endpoint of that vulnerability lifecycle, the race, at least for the defenders, I have to get those fixes out to my endpoints. And that is, again, harder again, because now I need to figure out, okay, if I go from computer to computer on my network, I have to figure out what patches does this thing already have, and have they been applied? Which ones are required? When do I deploy these? I mean, I might deploy something in the middle of the day, but I could drastically interrupt any business processes if I do that. People might have to reboot. What's a good time to do that? Well, never. So what's the least bad time to do it? Maybe 3 o'clock in the morning. All of those decisions have to be made, and then the patches actually have to be deployed, and I have to keep track of it. Just going to push the button and say, okay, I'm done, that's not good enough. I have to actually follow up and make sure that those patches arrived at those computers, that they were installed, that the computer was rebooted to make them effective, and all of those things. And so patch management is the mitigation part of the vulnerability management process for those vulnerabilities for which a software fix is available. That's not always the case. I might not be able to fix configurations with the patch management system. I certainly cannot fix people with the patch management system, but a good number of the vulnerabilities on my network I can probably patch automatically. I have to do it though, and it is an ongoing process. I can't do this once a year or once a semester or maybe even once a month. I have to do this on an ongoing basis because people write software and people make mistakes. So between vulnerability management as the overarching process and patch management as the process that focuses on getting the patches out to the endpoints, I have basically the core of what a vulnerability management process looks like. Now, vulnerabilities are difficult because different vendors might refer to vulnerabilities in different ways. And so we have a couple of tools for that. Maybe one of the most useful one is the National Vulnerability Database. It's nvd.nist.gov. The National Institute for Standards and Technology maintains that. What is interesting is that as a vendor reports on a vulnerability, that vulnerability is assigned a unique identifier, a CVE number. And so the benefit of that is that other vendors can also refer to that same CVE number. And even though everyone might talk about the same vulnerability slightly differently. If they have that CVE number, they can correlate those conversations, and you know that you're actually talking about the same vulnerability. The other benefit is that the CV is updated with information as to are patches available, or even what vulnerabilities are there in the first place. But all of this, of course, comes down to, do vendors report this to the CVE database? When I wrote my slides, and that's been quite a while now, I have to update this, there were 56,000 different vulnerabilities in there. I'm sure by now it's a lot more. There's some good descriptions there, and we'll take probably a look at some of those CVE entries when we do our assignments in class. Knowing what the vulnerability is does not help me in determining its impact. For that, I need to have some form of a scoring system where I might say, really bad, kinda bad, meh, okay, we can fix this later on. Now, for this we have something called the CVSS, the Common Vulnerability Scoring System. It is not a perfect system by a lot, but it is a system that is somewhat practical to use, and as a result, it's fairly widely adopted. In its most basic version, there are 3 dimensions across which we can measure. The first one is the base metrics. The base metrics are measurements of the vulnerability that are constant over time, and that do not change depending on where the vulnerability is located. We have a second and a third category, the temporal and the environmental metrics, that do change for temporal metrics with time. For example, this is a vulnerability for which there is no patch. That's a lot worse than there is a vulnerability for which there is a patch. Or an environmental metric, where I might have, for example, this is a vulnerability in a system that is not on the network. If that's the case, the risk of exploitation is a lot less, because it requires someone to physically interact with the device at that point. The problem is that both the temporal metrics as well as the environmental metrics, no matter how useful they are, they change, and anything that changes needs to be maintained, and maintenance is hard. And as a result, very few organizations, if any, really use the temporal and the environmental metrics in their environment, because it's just too much work to keep track of them. So we typically talk about the CVSS scores. What we mean is the CVSS base scores, the ones that do not change over time. That's to keep that in mind. Now, what do they look like? There are different versions of the CVSS, and every now and then the standard is updated. This is one of them. For example, we're going to look at the access vector. What does that mean? Well, it means that how close logically or physically do I need to be to this computer before I can exploit this vulnerability? Do I have to be local? So do I have to be on the same layer 2 network, the same local area network as the computer in order to exploit this? If that's the case, it will reduce the risk of exploitation, where if I'm across the internet and it doesn't matter where I am in this world, or maybe even as long as I connect to the internet, that would be a network connectivity. That would be worse, because now we have a much larger space that we have to worry about. Access complexity. How difficult is it to gain that access? Low, medium, high. Authentication. Can anyone invoke this vulnerability? An unauthenticated vulnerability, for example, is really bad. But if it's a vulnerability that can only be accessed by an individual who has successfully authenticated using multi-factor authentication, the risk of the vulnerability goes low, and the CVSS score comes down as well. And there's a couple other ones there. What's the impact of this on confidentiality? What is the impact on integrity? What is the impact on availability? Here we see our CIA triad again. All of those have an impact on the final outcome. In the end, plugging in those numbers gives you a score between 0 and 10, 10.0. But 10.0 is really bad, at least potentially really bad. Not all 10s are excessively bad, but most 10s are. So if you see a 9.8 or a 10, you really want to pay attention and probably make a decision to patch that sooner rather than later, if it's present in your environment, especially if it's present in critical locations. So in the CVSS scores, that's one of the first things we'll look at in practice, like how bad is this? If I have to prioritize anyway which patches to deploy, I'll go with the high impact ones first, and then I'll worry about the rest. So this Microsoft vulnerability in that DNS subsystem, that was a 10.0. Stop what you're doing, go patch this now. The CVSS is not the only one, the only mechanism to rate vulnerabilities, but it is one of the most commonly used ones. So here we have some basic ingredients that we can start putting together. We can measure how bad a vulnerability is by looking at the CVSS. We can unambiguously identify the vulnerability by looking at its CVE. We can then invoke our vulnerability management process to figure out, do we have this software on our network? How far behind are we? How bad would a compromise be? And what do I need to do to get the software deployed to fix it? And that software deployment mechanism, that would work through the patch management sub-process. All of these things together are hard to do, very hard to do, but they are essential. The more time that you spend on getting this right and automating this, and that's the key, because if this becomes a manual process, forget about it, you're never able to do that. If you can automate it, then you're in a reasonably good shape. It does not mean you're running a secure network or a secure environment, but it is more secure than it would otherwise be.